Hello everyone, my name is Ramtin Afshar, and here I'm going to briefly introduce our results to you, which is mapping networks using parallel kth-Hop Traceroute queries. So network mapping is the inference of the topology of communication networks such as internet, and a prominent technique is to use a tool such as Unix traceroute. However, mapping large networks require lots of queries, so our goal would be to minimize the number of queries. And because of the distributed nature of the problem, we are interested in parallel approaches. So the problem is as follows. We are given access to a subset U, which is the vantage point of a graph G, which is, the graph G is connected and unweighted with vertex set V and its set E. And we know the vertex set U, that subset. However, its set E is unknown. And we can access a black box oracle of kth-Hop queries, where kth-Hop query for vertex set U, and vertex V returns the case vertex on a shortest path from U to V. And our goal would be to find the induced shortest path graph H with vertex set U and edges in U such that we have two vertices such as U and V in vertex U connected if and only if the kth-Hop query for every value of the K return only vertices that are outside of the vertex set U, meaning that the shortest path from U to V does not go through any other vertex inside the vertex set U. And essentially the weight of each of these edges would be the distance from those two vertices. So for example, the graph would be as follows for this example. The key characteristic of our results are as follows. Our results are different from graph reconstruction, three main aspects. First of all, we introduce vantage point. However, in graph reconstruction, the vertex set U is actually equal to V. And we use kth-Hop Traceroute queries, which implements the parallel, which implement the inner loop of how the traceroute works, whereas in the graph reconstruction, the results are based on shortest path queries and distance queries, and our results are in parallel. However, most results in graph reconstructions are mostly sequential.